Okay, continuing where we left off, let's call this example 2. And again, it's going to be the same. We're going to solve. I'm going to do a part A and part B here next to each other. I'm going to work part A like I did over here, and I'm going to work part B like I did over here. All right, but they're going to be different problems. So part A, let's say, is 10 raised to the 5 plus 2x power plus 820 is equal to 49,600. All right, so this is quite a bit longer problem than part C up here, but there's some we can rearrange and rework some of this so it looks a little easier to work with. So let's do that. We have an 820 and a 49,600 here. So let's just go ahead and simplify that. There's nothing wrong, and it's not going to hurt anything. So 10 raised to the 5 plus 2x power is equal to, so I'm subtracting 820 from both sides. So I get 48,780. Now, what does this look like? Well, it looks like exponential form. It looks just like this one, except the exponent's a little different. But it's the same form. It's exponential form. So remember, we look to see if we can make the bases the same. Can we make the bases the same here? No, that's not possible. But then we need to look and see what form are we in, or what form are we close to, and can we make it into that form? Which we did that. If you look here at this step, you can see we were almost in exponential form, and just by subtracting that 820, now we're in exponential form. So that's what a lot of these problems are going to boil down to. It's going to boil down to you're in exponential or logarithmic form, and then to get your answer, all you have to do is convert it to exponential or logarithmic form, whichever one you're not in. So here we're in exponential form, convert it to logarithmic form. So I say, let's see, I have a log, and there's going to be an equal sign in here. My base up here is 10, so 10. Oh, I don't have to write that, remember? So we can fix that next time. If you write it, it's not a big deal. So we'll just leave it there for now. And then I want to get my exponent by itself. That's why I'm going to logarithmic form. So the exponent goes over here, and what's left over goes here. All right. So notice now I've got this x all over by itself, and this is just simple algebra now. I subtract 5 from both sides, and then I'm going to divide by 2. So let's subtract 5 from both sides. Actually, what I want to do is I'm just going to rewrite this without writing the base 10. Some of you can do this without writing the step out, and that's okay. But just so you have it in your notes. So subtract 5 from both sides. So here is here's a simple mistake that you can avoid. So this is log of 48,780. All right. This log 48,780 is a number itself. So if you were to put that in your calculator, you're going to get some number. All right, and you want to subtract that number from 5. Okay, be careful here, because some people subtract that 5 from this number, this 48,780, and that is wrong. It needs to be the log 48,780, then minus 5, and that's equal to 2x. And now divide both sides. Minus 5 all over 2, and that's equal to x. All right, so this is one way to work these types of problems. Part B is going to show you how to work it option 2 way. Now, I'm not going to show you this one. I'm going to show you a different way to get it. But you will still get the same answer either way. Okay, new problem actually. Here we go. 2,000 is equal to 18,000. E raised to the negative 0.4 t. That is negative 0.4 t. All right, so question. What does this look like? pause the video, maybe go back a couple, I don't know how many lectures, but this looks like something we've worked with. You know, take a couple minutes to maybe try to find it. So what this looks like is continuous compounding, the finance problems we did a while ago. So this is a real life example. This is saying that your accumulated value would be 2,000, your principal is 18,000, so this would be how much money you're owing. And then you're continuously compounding at a rate of, well, that's a high rate of, and then t. So what this problem is asking, if it was to be written in words, is saying when your accumulated value is 2,000 and your principal was 18,000 at a rate of this 0.4, how many years will it take you to get to 2,000? Your accumulated value of 2,000 left in your loan. So this is a way to be able to solve for t, and we're going to go over another problem like this here in a minute, written in words, and those will be good test problems too. So I'll tell you when the good test problem comes up, but this is very similar to a good test problem. So first, what we can do is we need to simplify this. We want to get wherever the variable is in the exponent, we want to get that by itself, completely by itself, and then we can go from there. But so this 18,000 is messing with us right now. So divide both sides by 18,000. So I'm just going to write it out first. All right. And then simplifying this 2018, you get 1/9. This 2018,000, excuse me. And here's what you have. All right, so you can notice that we are in exponential form here, and you can work it that way. But there's a faster way by using option 2 here. And I'm going to choose natural log. I'm going to choose natural log for a specific reason on this problem. Up here I just chose it to choose it. But here I'm going to choose it specifically because I have this e in here. And if you remember back several videos ago, we were looking at the shortcuts, and I didn't specifically write out all the shortcuts. I wanted you to be able to work them out. But the shortcut of the natural log of e to the 5th power, if you recall how to work that, that would be 5. The answer is 5. But if you didn't know the answer was 5, you could set it equal to something, call it y. Then the natural log you can rewrite as log base e of e to the 5th power, which is y. And if you remember the shortcut here, these e's cancel and your answer is 5. But still then, if you don't know that, you're okay. Because you're in log form, so you convert to exponential. So your base is e, and your exponent is y, and that's equal to what's left over, e to the 5th. So y is equal to 5. So, to get back to this problem, the reason I'm choosing natural log is because when I choose the natural log, this portion, natural log of e, just cancels, and I'm left with whatever's up in the exponent. That is my answer. So if I do that here, the natural log in e will cancel, and I'm going to be left with this all by itself. So, let's work it out. The natural log of 1/9 is equal to the natural log of e raised to the negative 0.4 t power. I know this will cancel out. Natural log of 1/9 is equal to negative 0.4 t. Almost there, just divide both sides by negative 0.4. Natural log of 1/9 divided by negative 0.4 is equal to t. All right. Which is, this will be approximately 5.4931 years. So that would, and I don't care about this for right now unless the problem specifically says how many years, then you would want to write out the answer. All right. Next up is another equivalence property. equivalence property. And this one is for logarithms, or the logarithmic expressions. So, and it's very similar. You have a log base b of x, and if that's equal to a log base b of y, that implies, what does that imply? It's similar to the exponential form where you had b to the x is equal to b to the y, and we set the exponents equal to each other. X is equal to y. So it's the same thing here. If you have log and the same base, then whatever's inside this x and these y's have to equal each other. So x is equal to y. All right, let's look at a quick example of that. All right, example 3, I believe. Solve, and we'll call it part A, just in case I decided on part B. Log base 2 of 3x minus 4 is equal to log base 2 of x plus 2. So I see here that I have log on both sides and the bases are the same. So this is only true as long as if you have a single log on both sides. All right, if there was a plus something out here or a plus another log, then you either have to figure out how to combine them to make a single log on each side, and they have to have the same base. All right, so that's important. They have to have single logarithm on both sides, just like the definition says up here. So we have a single log on both sides, and the bases are the same. So that means whatever's inside has to equal each other. So 3x minus 4 is equal to x plus 2. So add 4 to both sides. 3x is equal to x plus 6. Subtract x from both sides. And so x equals 3. All right. That's a good spot to stop for this video. We're going to pick it up right here on the next one.